Hey, welcome back. Today on my bench I have another HK 460i. This is the second one I'm going to be working on. This is the first one I did. I went through and I did a lot of work to it. I had to do lamps, I had to do capacitors, a few capacitors, and did alignment. And I really enjoy using it after I was finished with it. It sounds good. This is a really good sounding piece of gear. I love the design of it. Simple enough, but it gets the job done. This one here is a lot worse shape. Let me say, there's quite a few things that are wrong with this receiver, the way it stands. I did hook it up and test drive it for about a week, and the first few days it was barely listenable. I had to have the balance pot cranked over to one side because one channel was blasting the music so loud that there was a problem with balance. And then after a few days it kind of smartened up and cured itself, which is suspicious. There's something going on there. And then it straightened out and it started working great for about a week or so when I was listening to it. But it does have problems, a lot of problems. Let me go through some of the problems. First of all, it has a fever. This thing has a fever. It runs quite hot at idle, and I measured with the watt meter, and it's consuming about 43 watts at idle, which is way too high for one of these amplifiers. It should be down around 30 or less. Dial lamps are all burned out. I have no lighting whatsoever here. This auxiliary button is stuck. Can't push it in. I don't know why. The other four work. Now, like I said, the left channel was very loud. For the first couple days, it was really blasting out, and I tried, adjusting with the balance to the point where you could try and listen to it, but after a while it was getting a little grating on my nerves. And then all of a sudden it fixed itself and it went normal, and then both channels were equal again. But one channel or the other or both would drift in and out. They would be playing and then it would drift out into a quiet distortion, or it would just go quieter, or it would cut out completely. And that's probably attributed to a lot of cracked solder joints on the main board, I'm guessing. The tuning knob is seized. It's not totally seized, but I can turn it, but it's very stiff. But we're going to need to adjust this. And my bass knob here has a big bend in it. I don't know if you can see that. So we'll straighten this one out. They probably got damaged in shipping. Let me try a little bit of... Yeah, I might have to get a little carried away with that one. Okay. So let's try it. Power it on. Like I said, we got no dial lights. I'm on AM right now. First of all, let's try tape monitor. We're gonna feed no signal into this thing. The left channel's making a lot of noise. If I go to the right, I have a feeling there might be some DC on the left channel. That's what it kind of sounds like. Let's see. DC on the output. No, it's quiet. Very faint click or thump, which means there's very little DC on the outputs. So that needs to be addressed. Okay, we're on AM band. Let's try and tune something in here. Okay, we got a station. We got an audio that's very distant in the... Okay, that's why I got the monitor still on. That's probably the reason why.
That's true. Isn't that what we all do?
Do you have any idea
Okay, left channel is very
how
quiet.
many wild dogs exist
Right
in
channel is
New Guinea?
normal.
No, we don't. They're very hard to find. And I think it's encouraging to see that people are...
Okay, FM, auto. Picking up stereo stations. Right channel is very weak. That seems to be opposite from when I first tested it. The tuning cap sounds dirty. It's not great at picking up stations. It needs a... That's horrible tuning. Can you hear that? It's like there's dirt in the tuning capacitor. So I got my work cut out for me. Let's try phono. You get that scratchy sound on the left channel. It's a lot quieter. So, let's take the top off and have a look. Okay, I can already see a few problems here. We've got conductive glue all throughout this power supply section. It's all, and there's a lot of corrosion going on here too on some of these conductors. So I'll have to clean. These 4 filter caps are just flooded with the glue along the bottom. So that'll all need to be disassembled and cleaned. And just like the other 460i I did, this phono board is caked with a lot of glue as well. That's all going to need to be cleaned off. Like these capacitors are just swimming in it. So I'll do that. I'll remove that board, clean it. The rest of it looks fairly good. It doesn't look like it's a super high hours unit, but I will go through and check these capacitors, the few that are on the board here, and there's some back in the power supply. I'll just replace them out of regard, and then I'll go through the tuner and check some of these out as well. These are those TK caps, those green ones that I don't like, and usually I find a bad one or 3. Lighting. Well, the lighting's not working at all. But we'll go through and we'll get this thing hopping again. The tuning capacitor though, I think what I'm going to do first is I'll just take this outside and blow some dust out of it. There is dust buildup, but it's stuck to everything. It's almost like it's... So I'll give it a good blast with compressed air. Alright, so I'm looking at the bottom here, and I see one thing that kind of interests me is there has been, let's see if I can get into it. Maybe not. I don't know if you can see this on camera, but these capacitors, once upon a time, are glued down. And somebody's been in here scraping away at the conductive glue. Looks like they removed the majority of it, or most, all of it. But yeah, somebody's been in here working on this. And I think it had the conductive glue death here with this capacitor. And then they put a little heat shrink on there just to cover it. But I'm finding a few cracked joints. Let's see here. Cracked joints. Where did I see some? Nope. I saw one the other. Anyways, I'll go over it and I'll check all these joints here, especially these high heat areas, and I'll look for any cracks. I know there was some here. Here's one here, and I know there was some that I spotted when I first lifted the lid off, but we'll get through it. The tuner overall looks pretty good. I don't see anything going on here that would cause a concern. I just wanted, like the last one I worked on, it had all these bodges. Here's a cap, resistor, 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 cap, 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 cap. There's a lot of bodges on these. Okay, I'm going to start with the power amplifier and power supply. I'm going to yank these capacitors out and start cleaning all that conductive glue. I don't know if you can see that on the bottom there. Every capacitor is just flooded with. And see, there's some corrosion in between here on that jumper. This jumper's got corrosion. I saw some resistor here. Oh, there's a diode that's corroding around these two caps. So I'll take all this apart and clean it. See, with the caps removed, you can see the extent of the glue damage. There's some resistors under here that are corroded. There's two resistors. There's a diode here. Just gotta clean this stuff away. Once it's cleaned away, it won't conduct anymore. The board itself's not conductive unless it's burnt or been saturated in water or it's like a million years old. But you know, get rid of this glue. That's half the battle right there. And it's not, it probably was worse than I made it out to be, or not as bad as I made it out to be. But you know, just gotta clean all this stuff up. I did test some of these caps, and they're not looking too good, so I'm gonna probably replace those as well. Okay, so this is what I had to resort to tearing this thing apart. These switches, this switch here is still seized. But there's some kind of a crusty stuff that's in here. It's flaky, brown. Somebody sprayed something into these switches. See what that stuff is? It's all dried up and crusty now. I think it probably was some kind of lubricant. Somebody sprayed something that wasn't right in here. And then I have green corrosion going on in this switch. This switch. So I'm going to have to take these switches apart entirely and clean them because I don't know what's in there. And I think that's the best way to move with these. Either replace them, which I don't know if I can find these switches, but what I'll do is I'll take them all apart and clean them. And then if it comes down to replacement, then I'll worry about that road when I come to it. And then I can also access all the caps and clean the pots properly with cleaner and deoxit. Alright, so I'm looking at these switches and I'm not very pleased. Look at the green stuff that's coming out. This one still doesn't work. There's some kind of residue that's all over these switches. I don't know what this crap is, but it's crusty and it's brown and it's disgusting. I think it's something that was in a spray. I let this one, and you can see this stuff inside here. And it's caking up. I don't know if I can open these switches. They might be sealed to the point where I can open them. These switches here are a little different from the older ones. The lead spacing is 2.5 millimeters this way and this way. I spent a couple hours searching for replacements because I think it would be easier just to replace these than to rather clean them. But I can't find exact replacements. I can find some that are close. And what I've done is I ordered some 4-pole double throws and some 2-pole double throws as replacements. But they're not here yet. I don't know if this opens. Oh, maybe it does. Okay, let's take this spring. Let's try this. Oops. Let's just try opening one of these up. If we destroy it, well, it looks like it's coming. Get the spring held back. But it looks like they're glued. Yeah, they're glued. Probably split them open, but that won't do us any good. Oh boy. So, my only option is to spray stuff in and clean them. Spraying stuff in is okay, but it doesn't always flush out everything that's in there, all that crap. And I don't know what that crusty stuff is, so let's try some cleaning here. We're going to flood this thing. Yeah, I would love to replace these, but you see all the green in there? That's corrosion. Okay, I'm gonna and I don't even know what that stuff is. This is alcohol based, right? This contact cleaner. Hexane isomers, tetrafluoroethylene. Maybe it will dissolve petroleum based contaminants. Okay, well that's about as good as it's going to get. I think I'm just going to have to give it a good squirt of deoxit. I hope for the best. That's all I can do. That one seems like it's okay now. It looks cleaner on the outside. This one here, let's try the same on this. Let's pull this one off the bar because we got a mess here. Okay. Look at this. It's gross. Let's try cleaning this one. Shouldn't be getting this stuff on my hands. There's a good spot to spray it in. Another problem is with these switches is they have these 5 switch gangs, and they installed them on the board through the holes. And what they did at the factory is they folded over some of these pins to hold the switch in place before it was soldered. And when I come along to remove this switch gang, I tried lifting the pin that was bent over, and a lot of them broke. They only allowed one time to flex, and that was it. And I got 1, 2, 3, 4, 5, 6 broken pins, I think. So I have to repair those as well. It's a major pain in the ass. I'm gonna still see about buying these, because I've been doing a lot of HKs that use these switches, and it'd be nice to just have a replacement. That would be the best course. Okay, I'm going to wipe out any excess. I think I got it in there. It's hard to tell. Yeah, I think these are welded. They're welded on the seam here. I could bust them open, but then I'd never get them closed again. Okay, this switch here concerns me because this one won't even work at all. I'm going to take this one out, and we're going to try cleaning this one as well. I'm going to eventually take all these out and do them one at a time here, but I got to clean this bar. This bar is all caked with stuff in behind. This one has the spring on it. Let me lift that spring off. There we go. Okay. Very sticky. See if this helps. Spray some inside. I don't know what they sprayed on these switches, but it was definitely the wrong stuff. And looking at that residue, you can see this residue here. I don't know what that is. It's like a grease. Get the right stuff, guys. This one's still sticking. I don't know. I don't think that's going to do the business. It's not sticking anymore. Let's try lubricating it. Clean all this crap off. This is part of the main reason why these switches don't work very good, is because this bar is all gummed up and it's not sliding properly. You can see all the schmeg inside here. Just going to try and clean all this out. Look at that stuff, it's gross. And then what I'll use is I'll use a silicone lubricant. It's a nice light oil, and it's a very very good lubrication for mechanisms like this. You don't want to put a heavy grease. It's not what you want to see here. That's exactly what I'm cleaning out. It's like a thick, pasty grease. Alright, let's clean this some more. Well, if we can save this HK from the junk bin, I think we might have it here. With these switches are the deciding factor. Look at that, it's into everything. Okay. Remember which way this went. I think it went like this. It only goes together one way, so. Okay, I'll finish cleaning the rest of these switches. Some are done, some aren't. So I'll do that, and then I'll reassemble and see how it works. So now that I got the locking bar cleaned and I'm starting to reassemble, what I want to do is lubricate that locking bar. And I'm just using silicone lubricant. This is a good high performance lubrication. It's got a lot of solvent in it, but what I mean is when you spray it, it's pretty voluminous. Spray it in, kind of foams up too a bit and gets in all the crannies, and then what happens is the solvent evaporates and you're left with that silicone lubricant in it. So it's a light, very light gauge oil or super silicone lubricant. It's very low viscosity, and that's starting to work a lot better than before. Those are yes. Okay, so let's continue. I'll put these switches, clean these and put these back in. This one's not clean yet. Okay, just a little update here on what's been going on. I completed the switches and got them soldered back in. They are working now. Working quite nicely. These other switches, I cleaned them up and everything's back together. I'm going to start putting things back together now. I got the tone board recapped. I've got everything recapped. The tuner is recapped to the point where I changed out, power supply capacitors, bypass caps, and these I have not yet tested. I'll test these to see if they're worthy of staying. Got the caps installed. This little power supply board here I made some modifications to. What I did, you can see that, yeah, you can, I think. There's a little resistor here that was for the dropping resistor for this little lamp that's on the dial indicator. I removed that resistor, replaced it with a diode, and I reconfigured this little, I had some unused printed circuit board space here, some copper traces on the back, and I reconfigured it to be a little power supply for the LED lighting that I'm going to install. So what it was is it had these two green wires from the transformer. I don't even know what voltage it was, but it comes here, and then from here they tapped on all the 3 lamps. There was 3 incandescent lamps. So I changed that, turned it into a little halfway rectified DC power supply with a little filter cap just to smooth it out so there's no strobe. And we're going to take DC voltage off of here now for our LED lighting. So we'll get to that, but I made that modification to that board, reinstalled it. What else is going on here? It's just a matter of putting things back together now. I was looking at these driver transistors. Yeah, let's have a good look at this. There's a metal plate here. It's about 1 inch by 1.5 inches, 2 inches. And what it does is it provides a thermal connection for all these 3 transistors. So these 3 transistors are hopefully at the same temperature and cooled by this little heatsink they created. But you can see that some of the compound on these transistors is dried up, and I definitely have gaps between the transistor and the plates. So I might want to take these transistors out and re-lather them with grease so that they make good thermal conductivity, and then put it back in. So that way the amplifier will be thermally stable on these things. This one's not too bad on this side, but you can see that on this side. Maybe not. So it's just a matter of putting things back together again and trying to get it all working again. So switch is done, which is a incredible pain in the ass. Took me a lot of hours. So it's just a matter of reassembling the rest of this now. Put this back together and put the front chassis plate on and get the lighting done. I think that's the last step, is the lighting. Okay, a lot of people shy away from working on receivers because they have the dreaded dial cord spaghetti mess. But let's work through this today and see. All I did was I pulled the string off and I left it, and it's been dangling and everything's tangled up. So let's see if we can restring this without using a diagram. It's really not that difficult. You have your drum, and your drum usually has a spring-loaded tensioner, and that's it there. And that's in the relax mode, and that's in the tension mode. But it's pretty simple. It's a little frustrating because you have to get the string in a certain groove type thing, but it's not a big deal. We can do that. Let's try this right now. Let's take this off. Okay. So that's our first wrap. Let's put this on. Okay. Okay, it's in the groove, and we need to get another wrap on that. So I'll get. It's good to have a hook tool like this, and you can feed it where your fingers don't fit. So I make sure it's in the right groove, like it is there. Now, I think that's it. I don't need any more wraps. This goes across the top. Pull it the opposite way. How come I got so much string? I gotta put one more wrap on, I think. Yeah, I'm off here, one wrap. So I gotta put another wrap on. Just want to see if I can do this on camera to show you that it can be done. It's not as difficult as everybody makes it out to be, but it's just a little patience and fiddling. Okay, I got 3 wraps on there now. And you go in the service manual and take a look. You'll see a diagram of how it's supposed to be. I'm going to not look at that. I'm just going to go from memory and try and figure things out, because there we go. There we go. That goes there. Okay, which way is up on this thing? This is backwards. Okay, so you know what I did wrong? This goes on the lower. This goes on the lower pulley, and then it gets wrapped 3 times around the tuning knob. And I'm not sure if it goes over wrapped or under wrapped. We're going to put 3 wraps on here. I got 2. Get one more. 3. And then we got our wires in the way here. Let's turn this like this. Okay. This one up top. Before I go any farther, I want to fix this. Okay, well, that's on the drum. That's on the pulley. 3 wraps. Let's see what we can do here. Pulley, tighten this up. Okay. Okay, I got everything strung properly, except it's overlapping here. Two things. I have the cord wrapped the wrong way around the tuning knob, so I'll fix that right now. Pull this off, 2, 3, and then we'll reverse that. One, two. It's 1 wrap, 2 wraps, 3 wraps. There we go. Okay. We're still short about 4 inches of cord here. Why? What we're going to do, maybe I have too many wraps on this thing. Let's take one of these off. It's got to be the reason. There we go. Take this off. And place it on these 2 pulleys. Okay. We're getting there. That's supposed to be. Okay, our spring tension. Oh boy, I gotta get this fixed. This jumped off this tub, this roll drum. So let's just put it back on. We're just about there. We're just about done. Oh, you want to be difficult, huh? Okay. So you want to put up a fight? Let me take this off. A little slack here. If I could keep tension on it all the times, it would be easier, but you can't do that. Okay, let's see if we get the slack out of this thing. What am I missing? That's too few wraps on there because we got too much slack. Way too much slack. This slack, that's how much slack I have. Why? This is correct. Oh, I only got one wrap on here. Why I got one wrap? It should be 3 wraps. 1, 2, 3. Okay. This is correct. This is correct. This is, I'm pretty sure, is correct. There it's going. It's going into place now. There, it's done. Now we need to figure out this tangled up mess. We are not having enough tension on here. Okay, you know, I need another wrap on this. And we're going to do that right now. We don't have enough tension on the cord. So we're going to put another wrap on this. Come on. Doing. There we go. Four wraps on that. Okay. So I had some alignment marks here before we disconnected it, and that lines up, and that lines up, so everything's good, and it's working. Just test it through its full range. Everything's good, nothing's... There you go. Okay, before I go any farther, I want to find out what my voltage is across from my little power supply. I don't even know. I got the main fuses pulled for the power amplifiers, and I think the only thing going to be on is this secondary winding for the lighting. Turn this on, and let's see what we got here. 19.3, which is kind of what I expected. I expected to see 19 volts. and that is unloaded with open circuit. So I'll do my calculations for my LED lighting for 19 volts. Alright, so here's a drawing or a schematic of the power supply for the HK 460i. It's pretty simple. Power plug, 4 amp fuse on the input, power transformer, main winding for the power amplifiers and everything else, and then there is a secondary winding for the pilot lights alone. And this is the way it's wired from the factory. Straight out of the transformer we have two windings, two conductors. One, they're both shunted to ground with these two capacitors to reduce any stray buzz or noise. And then it goes into the two incandescent lamps, one in each side of the dial scale. There's two. And then there's a 39 ohm resistor, half watt, and then it goes to the pilot dial pointer indicator. There's a tiny little bulb in the pointer. So 3 bulbs total. Pretty simple circuit. It's all run on AC, and it's protected from noise from these two capacitors. This 39 ohm resistor drops the current for that little bulb, so it's not stressed so bad. But that's the way it was. This is what I'm replacing it with. Have the transformer secondary here. The two capacitors, 0.01 microfarads. They're still going to be going to chassis ground. I removed this little resistor and put it in its place. I put a single diode. So we're getting halfway rectification here into a 470 microfarad capacitor. And this is going to give us 19 volts DC. Now for the lighting, I'm going to use these LEDs here for the dial scale. These LEDs have two, they have two LED chips inside. So when I put two in series, it's going to be 4. So using these chips here, I'm going to put these in series. So I'll have a total of 4 LEDs in series with these two chips. And then I'll have one on one side, one on the other. And that'll provide plenty of light to flood that dial scale. So that's why I drew 4 LEDs in here. Now this dropping resistor we haven't figured out yet. And this one we haven't figured out yet. They'll both be the same. For the dial indicator on the tuning indicator, I'm going to use a single warm white LED, this one here, and it's going to be a single LED, so this resistor will be different, but I'll figure it out shortly here. If you add up the voltage drop across these 4 diodes, it's going to be somewhere in the order of 12 volts, I'm guessing, or 12 or 13 volts minus 19. That leaves me with 7 volts drop across this resistor. So I'll calculate this out to be about 10 milliamps on this leg, 10 milliamps on this leg, and maybe 5 milliamps on this leg, for a total of 25 milliamp draw, which isn't very much. So I don't expect anything to get overheated, and I expect it to have a nice long life. So I'll get the calculator out and figure this out here. Okay, I just did a few calculations, and considering that each voltage drop across each diode is about 3.2 volts average, I'm just going to go average. So that makes a 12.8 volt drop across here. The remainder would be whatever that is, minus 19. So it'd be 6 point some volts. So in order to get 10 milliamps on this leg, I need to put a resistor in here that is 620 ohms. And that will provide enough current drop to to allow 10 milliamps flow through this leg and 10 milliamps flow through this leg, or pretty darn close to it. 620. 620 is not a standard value. So what I'm going to do is I'm going to change it to 680. And that will drop the current probably maybe 9 or 10 milliamps. Doesn't really matter. We're not going to get that much difference in light output. So these resistors here will dissipate about 60 milliwatts each, which is far below a quarter watt or even an eighth of a watt dissipation rating for a resistor. So we'll be safe there. This resistor is going to be dropping 19 volts minus 3.2. Let's get a calculator and do this. Minus 3.2 is 15.8. So we want about 5 milliamps through that. I equals E over R. Divided by 0.005, and we get 3.16K for the for here. Now the next closest standard value is 3.3. Yeah, it has to go to 3.3. And dissipation for this resistor, if it were 3160, it would be approximately 80 milliwatts. 80 milliwatts here, which is still under a tenth of a watt, so we're still good for that. Okay, so I'll get ready putting this together. And what I'm going to do for the dial scale is I'm going to remove these bulbs. And I'm just going to build the circuit right on here with the 2 chips and a resistor right on this little printed circuit here. And that's what we're going to use for our illumination. Okay, here they are. I'm done. Got 4 LEDs wired in series. They're hot snot to this board to stick them down. What I did is I cut a trace and I put a 680 ohm resistor in series. So everything's on this one little board, and just to test it out, get positive hooked up and negative. Oh, got it backwards already. Negative and positive. So there's my light source for the dial indicator. Not the dial indicator, the dial scale. And this is not even drawing 10 milliamps. So this should run cool. No temperature. This side's positive. This side's negative. That one's working as well. So yeah, all I gotta do is wire those in. So like everything in life, nothing calculates out the way it should be. So what I did is I reran the numbers. After I built the circuit and it's working, I powered it up and I tested the voltage on the output of this power supply, and it's not 19 volts. Actually, I measured 19.3 volts with 0 load on here. No load. And then once I added the LEDs, the load brought the voltage of the power supply down to 18 volts even, which is a 1.3 volt drop, which isn't bad considering I'm using half-wave rectification, and you know, it's not the most efficient use of energy, but whatever. So I recalculated the numbers, and I have 11 milliamps in this string, 11 milliamps in this string, and 4.5 in this string, for a total of, what does that make it? 22 plus 4.5 is 26.5 milliamps total. And if I do the math on that, driving it with 18 volts, 26.5 milliamps, that works out to less than half a watt. It's 460 milliwatts, something like that. Which is an improvement in efficiency. Not that it makes a big deal, it's not that big of a deal, but for comparison, I just did, for the hell of it, I calculated out what the circuit would draw if it was the original lamps installed. So they were using 15 volt 100 milliamp lamps, and for the dial indicator they had a 12 volt 60 milliamp lamp through a 39 ohm resistor. So if I do the math for all this, the receiver will consume 3.3 watts just to light up the front panel, and we dropped that down to less than half a watt, so it's a bit of a savings as it matters. So let's have a look at what it looks like. So turning it on, as you can see, the lettering is nice and bright. It's a cold blue, or not cold blue, but cold white. I use the cold white for the dial. I used a cold white for the dial and a warm white for the dial indicator. You can see it sliding around there. And turning off, it seems to extinguish quite a... Here, let's turn these lights off and get a better look at it. The 470 microfarad capacitor has a little bit of lingering here, so let's just try it, shutting it off. And you see the dial lamps go out fairly quickly, and this takes a little longer to extinguish because it's a single LED. But I don't think that's offensive to anybody, the way it shuts off. It just kind of goes to sleep. So what I could do is I could replace that 470 microfarad capacitor with a 330, or even a 220, but I wouldn't go less than that, because you don't want to get the strobing from the LEDs from your 60 hertz power supply. Okay, I got it back together enough that we can start doing some testing. Good news is everything seems to be working. Bad news, we got some heavy distortion on the output, and I'm just trying to pin down where it's coming from. It seems like it's coming from either the preamplifier or the main amplifier. The tuner seems good. The tuner seems to be working fantastic. Everything else seems to be okay. But I just want to check, first things first, I want to check DC offset on the outputs, because I don't think I ever have checked this. And fluctuating. I don't know if you can see that. This is the left channel, I believe. So it's bouncing all over the place. I don't know what's going on with that. Let's get a different meter. Hey, can you see this? I hope so. So let's turn this on. We got a problem with we got a problem in the amplifier. The output is floating around like that. That shouldn't happen. Let's see, it's floating around 0, it's going positive, it's going negative. Here, I'll put it back to DC positive. Okay, it's going positive, Goes negative, positive, negative. Okay, so let's try this other channel. Is it the same or? It's the same. So we definitely got a problem in the power amplifier somewhere. And I did clean out the conductive glue. What channel am I on right now? I'm on the right channel, aren't I? Right channel. This is odd because you got a problem that affects both channels. And that's why I'm leaning towards the preamplifier section. I replaced the caps in the preamplifier, but maybe there's something I missed. And it seems to affect both channels. Let's try the other channel again. I remember when I was test driving this amplifier before, it would run quite hot and it consumed 43 watts at idle. So something's definitely not right there. Either the settings were off or this is unstable. Okay, well, shut the speakers off and it stops. Alright, so I'm just troubleshooting here, and a few things I've done is there is a plus minus 15 volt supply here. It's regulated with Zener's, and I checked the output of this. This is rock stable at 15 volts, and this feeds to the preamp and supplies power for this preamp. So the voltages to these preamps is stable. Now another thing I checked is I checked on the input capacitor of the power amplifier. It's 100 microfarad on both channels, and I'm just looking at it here. If I look at before the capacitor, if I touch the probe, I can see the meter deflecting. I don't know if you can see it on the camera. I got it down to its lowest range, 0.3 volts full scale deflection. And you can see the meters jumping. Barely, you can barely see it. I don't know if the camera's picking that up. See how it's twitching around? Here, I'll try the other channel. Same thing, it's twitching around. Now let me test the, before I fry my meter, let me turn this. This is the amplifier side of the see, that's twitching around as well. That is on the amplifier side of that capacitor. Now if I take, let's see here, what I'm going to do is I'm going to test around this preamp to see if I can find any instability. So I turned down the bias, and because this thing was really cooking, it had an overly biased setting, and it was running really hot. So I turned that down, but it's still, look at this, on the output of the speaker terminals, it's just freaking out with DC offset. Now I think I'm going to have to break out the scope to see where this is coming from, because it's present on the input of the amplifier, But then I checked on the output of the preamplifier and I didn't see any movement. Let's see here. This is the preamplifier. It goes through tone controls, bass, treble, tone defeat, and then it goes to these two lines that run to the power amplifier. These two lines come straight into the power amplifier, 100 microfarad cap, and I found that weird voltage on those two caps. So, but I went back and checked and there was nothing. So it's something around this area that's affecting both channels. And I still haven't, might be a bad ground. It could be a bad power, but I checked the power, it seemed okay. But I'll have to get the scope out here and get a better look at it, because this meter's not really showing me much other than what's on the output. When I start it up, there's a huge DC offset. Let's try this. It kicks on. Huge, 3 volts. And then it settles down. So something's going weird here. Okay, I think it's time to divide and conquer here. I think I have a signal that is coming in on both power amplifiers, because both power amplifiers are separate, completely separate from each other with regards to power supply. Everything's separate. So what's affecting one channel shouldn't affect another. That's why I think it's before the input to the power amplifier. Which I'm going to do here is I'm going to connect up my meter again. What I'm going to do is I'm going to disconnect the input on one channel, the right one, let's say. Yeah, I'm hooked up to the right. So let's pull that pin. Let's do it this way. Getting tangled up. Let's see here, I need a pair of needle nose. Let's grab this pin and pull it out. Okay, let's try it now with that right channel disconnected from the input. Alright, sorry for the interruption. I got the input for the right channel disconnected, and this is the output. It's rock stable now. I can go in and I can adjust the DC balance. Let's see, make sure I get the right pot here. DC balance is right channel V401, which is this one. Okay, so I can set this to 0 now. And it's stable. So nothing is wrong with this power amplifier. But let's check the other channel now. And I'll bet you it's still going wonky. Yeah, still jumping around. Let's check the voltage on the right channel input. And I can see the meter twitching around. It's not much, but you can still see it twitching. So we got something wrong with that preamplifier. And that preamplifier is, let's see here, where is it? Preamplifier is down in here. So I got a problem with this board, or those transistors, or something. Alright, I believe I found the problem. This wire is broken off here. And this wire is actually, let's let's see here. This is my X line. This X line. This is a plus 13.2 volt supply for the preamplifier. The minus 3.2, minus 3.3 supply comes off the X and Y. So I got minus 13 volts, but no plus 13 for this amplifier. So that's my problem right there. And it was passing a signal. Let me see if I can connect this and without shorting something out. I just want to touch it to the post. Here, let's turn this. Okay. And that should stabilize. Doesn't want to stabilize. Yeah, it's just settling. Now let's check. My instability is gone. Everything's settled. Now it's at 0 and it's no longer fluctuating. So I just got to solder that wire back and we're all back good again. And break my meter. Okay, so I'm back. I soldered that broken power wire back on and we're going to do another test, and it sounds like it sounds good now. We're getting full fidelity. FM stereo is working good.
Challenging times, it's even more. You've been dreaming about it. You're
Might need a little bit of a tune-up though. I'll go through and check the alignment. It seems like the dial, the tuning capacitor has cleaned itself because it's not so scratchy anymore. Just let me. It was really bad on the low end of the band here, but it seems like it's cleared now. Let's try AM.
Working on these big, huge hits with these huge artists was rare, and she's doing some really cool things.
Seems like everything's working, so we can do some testing now. These are some of the caps I replaced, or actually these are all the caps except for the power supply filter caps. So far these ones are reasonable, but these ones are garbage. They're high ESR. They've lost maybe 50% of their capacitance. Maybe 3, 4, sometimes they're 10 times the ESR that they should be. So these caps are old, tired, and time to go. And when it gets to this point, you might as well change out all of them and be done with it. And you can see there's a lot of circuit glue I was fighting. It was all over the place. And yeah, so overall I think it turned out well. Oh yeah, and 3 incandescent bulbs were replaced with LEDs. Alright, we're all wired in for a power test. I got my dummy load, scope, RMS voltmeter. So I got it hooked up to a signal source, 1000 hertz. Let's turn this on and try this out. Let's see. Subsonic's working, solid loudness. Let's take this down to, it's at 40 hertz now, let's take it down to 10 hertz. That's quite a bit of effect on the subsonic, I guess. Tone defeat, tape monitor. Okay, let's bass. Balance. Stereo blend. Let's put the dummy load on. Turn it up until we get clipping. And we got a circuit breaker cut out. That's the left channel. Those circuit breakers are the weak point here. Okay, let's the frequency back up to 1,000 cycles. There we are. Turn this up. Clipping's right there, and I'm getting 18.6 volts RMS on the output. Let's see if that breaker goes again. It's getting quite warm. There it goes. This channel's really hot. What channel is this? That's the right channel. Okay. Let's turn this down. Take it up to 20 kilohertz. And let's see what we got here. Clipping. 17.7 volts. I did a bias adjustment and DC balance adjustment to set it off to the right spot, and once this cools down I can check it again. They can't check it when it's hot like this. It's got to be normal idling temperature. It looks like that circuit breaker is no longer stressed. A little bit of distortion there on the top. Treble control. Puts it into clipping. Let's take this up to a higher frequency. That is 82 kilohertz. And we're down to 16.6 volts RMS. Full power output. It's actually holding out pretty good. Okay. So I'm pleased with that. Let's check a square wave. Let's put it back to something more reasonable. 20 kilohertz square wave. Right, there's clipping. Didn't like that. Both channels didn't like that. Now I can smell something hot. It's pretty good. There's no ringing. Let's turn up the treble. Right into clipping, yeah. It's a pretty stable amplifier. So yeah, I think it's turned out pretty good considering what was all wrong with this thing to start. It was pretty much a basket case when it came in here. It had a list of things wrong with it. These buttons were not even functional, but now they're all working great. You know, that was the hardest part, was cleaning up the switches on this thing. Just getting at them and cleaning them was an incredible pain in the butt, but I think it was worth it in the end. I got a nice clean sounding machine now, and I think this is going to make the new owner happy. So I'm just going to wrap this one up here. I'm going to disconnect this and wrap this one up. There we go. That finished. All right. Thanks for watching.